Let's go to page 245 and start with number 398. Okay, 398, the picture is given. Okay, so it's triangle ABC with AB perpendicular to BC and BD is the altitude to AC. So BD is the altitude to AC and AF by 6 BAC, AF by 6 BAC. Okay, so AF by 6 BAC, AP equal to 12, and PF equal to 8. Okay, find tangent of angle BAF. Okay, and find PD. Right. Okay, so first let BF equal to X and AB equal to Y. So this is Y and this is X over here. So what we're looking for is tangent of angle BAF will equal to so tangent of BAF would be opposite over adjacent would be X over Y. Okay, so now we have to look for the X and the Y. Okay, so this is the import, so that's what we're looking for. So kind of keep that in mind. Okay, so angle BAF is congruent to angle PAD because this is the angle bisector, so they are congruent. And you got angle ABF is congruent to angle ADP. Okay, so let's go and mark this. Okay, and ABF and ADP. Okay. So, and the reason for that would be right angles are congruent. Okay. Then we have a triangle ABF is similar to triangle ADB, and this came from AA. Okay. So what we have is we have this triangle and this triangle over here. Now if you were to redraw the triangle, this is what you have. You have A, B, F, and you have the A, D, P. Okay. And AP equal to 12 and AF equal to 20. Okay. So AF is 20 and AP is 12. So the scale factor is equal to 12 over 20. So scale factor equal to divide by 4. You get 3 over 5. So that's your scale factor. And we know that BF is X, so DP would be from here would be 3/5 x. Okay, and AB is y, so AD would be 3/5 y, right, using the scale factor. Okay, what we're going to do next is we're going to apply the Pythagorean Theorem. So we're going to look at this triangle. So look at the triangle. So for triangle ADB, so you got AD squared plus BD squared equal to AB squared. Okay, so AD from here is 3y/5 squared, and BD we don't know, that's what we're looking for, and AB is y. Okay, so that's going to work it out. And actually, if you look at this, is 3/5, 5/5. So you can BD is going to be 4/5. So this is a 3, 4, 5 triangle. Okay, so you got 3/5. 1 is 5/5. So it'd be 4/5. Or you can just use Pythagorean theorem to work it out. But it's quicker, just recognize that it's a 3, 4, 5 triangle. So BD will equal to 4/5. So again, this is 3/5, 4/5, 5/5, right? 3, 4, 5 triangle. Okay. So that's another important information. Okay, now what we're going to do is we're going to use the angle bisector theorem. Okay. So we're going to continue. So use the angle bisector. Okay, so for angle bisector theorem, you're going to have AB, so this over this, equal to this over that. Okay. Okay, so AB is y, BP, okay, BP we don't know. Okay, AD is 3/5y, and PD is 3/5x. Okay, so flip it over. Flip it over and move the y over. Well, we can cancel this out and then cross multiply xy/y. So BP equal to x. So that's another important information. So once you find this is equal to x, we can put it over here. So this is x. PD, DP is 3/5x. Okay. Okay, next what we're going to do is look at this triangle again. Okay, so you got BD equal to BP plus PD. Okay, so again, this equal to this plus that. And so BD, so PB, BP is x, PD is 3/5x. So BD is equal to 8/5x. And remember from earlier, this information over here, we have BD equal to 4 over 5y. So we can put over here from here. Okay, BD equals that. So now we can go ahead and look for the x over y. Okay, so first, let's go and move this over. So x will equal to 4 over 5y over 8 over 5. Okay, so move this down. And then we're going to move the y over. So x over y equal to 4 over 5 over 8 over 5. So x over y times by 5 times by 5, you're going to get 4 over 8. And so x over y equal to 1/2. Okay, once we find x over y equal to 1/2, then we can find the tangent. That's what we're looking for. Tangent of angle BAF is equal to x over y. So tangent of angle BAF equal to 1 over 2. Okay. Okay, now next thing we need to do is look for PD. Okay. Okay, so we're looking for this over here. Okay, so to look for PD, we look at a triangle ABF and apply the Pythagorean Theorem. So got AB squared plus BF squared equal to AF squared. So basically we're solving for x. We try to solve for x. Okay, so AB is y, BF is x, and AF, okay, so AF is 20 because you got 12 and 8, so that's 20. And y equal to 2x because from here, so you can see that x over y equal to 1/2, right? So if you cross multiply, you get y equal to 2x. Okay. So we're going to substitute, so you get 2x squared plus x squared equal to 400. And simplify this, you get 5x squared equal to 400. So x squared equal to 80. So x equal to 4 square root of 5. So once we find x equal to 4 square root of 5, then we can find the PD. Okay. So PD equal to 3 over 5x. So PD equals 3 over 5 times 4 square root of 5. So PD equal to 12 square root of 5 over 5. Okay. Let's go to the next one. Okay, so the next one, you have the diagonals of a trapezoid is they are perpendicular. So let's go and draw the perpendicular first. Okay, and by definition, the trapezoid means the top and the bottom would be parallel. So if we were to draw parallel lines, okay, it doesn't matter where we draw it, okay. And what you're going to see is that in order for this to be to fulfill these conditions, this is actually end up with a parallelogram. Okay. So you're going to end up with this kind of situation. So let's just go and label. All right, so let's go and label A, B, C, D, and this would be the E. And so what you want to do, you want to draw the parallel to the AC. So draw that and call this F. Okay. So you can see from here, so this whole thing is 9, and this is, so if you go over this, it would be 7, and this would be a 9. Okay. So if you look at this right triangle, you have BF square plus BD square equal to DF square. Okay, so BF is 7, BD is 9, okay, so DF equal to square root of 130. So this is square root of 130. And actually this is a parallelogram, so this and this are congruent, and so when you sort these, this will be congruent also. Okay, so DF is actually twice DC, so this is equal to 2 times DC. Okay. And so you're looking for the median right over here. Okay, so since DC is, so this is equal to 2 DC, so DC will equal to half of that would be square root of 130 over 2. Okay, so this would be square root of 130 over 2. And this would be square root of 130 over 2. Okay. Now because it's a parallelogram, so the median would be actually equal to that. If not, you can add, divide by 2, you get the same thing. Okay. So the median will equal to square root of 130 over 2. Again, the reason for that because DC is that, and this is also equal to AB, because this will end up being a parallelogram. Okay. And again, when you average the two of the same thing, you end up with the same thing. Okay, let's go to the next one. Okay, number 400, the picture is giving. Okay, so you got triangle A, B, C has an area equal to 10. Point D, E, F are all distinct points from ABC on side A, B, B, C, and C respectively. AD equal to 2. so let's go and draw all these points. So I draw extra line over here. Okay, so AD equal to 2, DB equal to 3, so this is a 5. If ABE in quadrilateral, so if ABE in quadrilateral DBEF have the same area. Okay, so what is this area? Okay. So the area of ABE, the blue one, equal to area of DBEF. Okay. So you can see that in this case, these two areas would be equal, right? Because this part all equal out, right? So this would be equal. So these two areas be equal. So area of A. So if first what they do is they negate this part over here, okay? Because this is reflexive, right? They are equal to each other. Okay, so area of ADE is this little triangle over here, equal to area of FDE. And if you turn it sideways, they have the same base, so they will have the same height. Okay, so they will have the same height. And since these are parallel lines, since if you look at the height, right? So you're going to have actually congruent triangles. You can prove that they are congruent. So FE is equal to AD. Another way you can do this is that since this can negate out, so this will have the same area, okay? And okay, what else? Okay, so FE equal to AD and AF is parallel to DE. Okay, so anyway, these two are congruent triangles, and therefore everything's all parallel. Okay. So these are parallel, and therefore you have to use a scale factor. So triangle DEB to triangle ACB is 3 to 5. Okay, so look at this triangle and this big triangle. It's 3 to 5. So this is a scale factor. Then the area ratio is equal to 9 to 25. So the 9 over area of DEB So anyway, so this is, so basically what you do is you draw the big square like 25 and the small one is 9. Okay. So 9 over DEV, because you don't know what is the actual area is. Okay. So this over this will equal to 25 over 10. Okay. So another way to do is you can use, okay, another way to write the ratio is use 9 over 25. Okay, so small over big will equal to the area of the small over the big area. So this is probably easier to understand rather than this. Okay, so use a ratio. So small area over big area equal to small area over big area. Okay, so this is a ratio and this is the actual area. So cross multiply, you can see that k equal to 90 over 25. So k equal to 18 over 5. Okay. Okay, so this is a DEV. Okay, so once you find the area of the DEV, so k of DEV equal to 18 over 5. So we got 18 over 5. Now to find out this area over here, we need to divide this by 3 times by 5. Because this is 3 and this is 5. So area of AEB equal to 18 over 5 divided by 3, right? Divided by 3 times by 5. So area of AEB equal to 6. Okay. Okay, let's go to the next one. Okay, so again, the picture is giving. This is A, B, C. Okay, M is the midpoint. And AN is the angle bisector. And BN and AN are perpendicular. Okay, if side AB and AC have lengths of 14, so AB is 14, AC is 19. Okay, find MN. So you're looking for this over here. Okay. So first what we're going to do is we're going to extend this out here and call this point E. Okay, so you have triangle ANB is congruent to triangle ANE. So these two triangles are congruent. And the reason for that because a right triangle, and so you have the SA, okay, or you can use ASA, okay, so they are congruent triangles, right? ASA, okay. So once they are congruent, and therefore this would be congruent to each other. So from this you can see that N is midpoint of BE. And also from here, from the giving, M is midpoint of BC. Okay, so if this is a midpoint, this is a midpoint, then MN is median. So from this, MN is a median of triangle BEC. Okay, and therefore MN is parallel to CE, and MN equal to 1/2 of CE. Okay, now by congruence, this is 14. Okay, so AB is 14, this will also equal to 14. And if this is 14, this would be a 5. Right? Again, by congruent triangle. So congruent triangle, so from here, AE equal to AB equal to 14. And from here, you can see that CE equal to 5. Okay, because 19 minus 4 give you 5. So from here, we can get MN. So MN equal to 1/2 times 5. So MN equal to 5/2.